Dave Staublin here, and we are going to talk about sequences and series. Now, let's say that we have a sequence and it looks like 2, 5, 8, 11, 14. Now, this would be a sequence because it is an ordered set of numbers. And let's use our knowledge that we have so far, and let's write an explicit equation for this. Well, the first thing we need to determine, is this arithmetic or is this geometric? And I'm looking at this and I'm seeing it starts with 2 and we're adding 3 each time. So if we're adding 3, it's an arithmetic sequence, and we know the starting value is 2 and the common difference is 3. So the explicit equation will be 2 plus the common difference n minus 1. Okay? Now, here's the next part. If a sequence is an ordered set of numbers, a series is a sequence of numbers that is added together. And you may recall from our last video that there are infinite series and sequences, and there are finite sequences and series. And we now have a series, and it is finite because it has a specific start and end location. Now, if we wanted to evaluate the series, we would add all of these numbers together. We would do 2 plus 5 is 7, and then we would add the 8, which makes 15, and then we would add the 11, which makes 26, and we would add the 14, which makes 40. So to evaluate this series, we would find out that it equals 40. Well, it turns out that there is mathy notation to represent this series. And let me explain to you how it works. So, a series means that we're adding together or that we are summing the numbers. Sum means add. And it turns out there's a Greek letter called the sigma, which is the Greek for capital S, and it stands for sum. And so what we would do is we would say we want to sum this series of numbers. Well, what is the equation that represents this sequence of numbers that we want to add up? Well, that's this explicit formula. So we could write the sum of 2 plus 3 n minus 1, and so far this math notation is telling us we're going to add up all the numbers that are represented by this equation. Now the problem is we don't know how many terms this equation is supposed to represent. So let's count them up. We have n is 1, 2, 3, 4, 5. So what we want to do is, this n represents the term number, so we write n equals 1, because that's the term we're going to start with, and then on the top we're going to put a number 5, because that's the term that we're going to end with. And so now we have used summation notation to represent this series, which is, we're adding up all those numbers. Okay? So, here's what we know. This symbol is the Greek letter sigma, which means sum or add together. This is the explicit formula for the sequence of numbers that we are adding up as a series. This is the first term, or the starting term, that we want to add. And this is the ending term that we want to add. Okay, and that's how it works. So, given this function, or this summation notation, let me show you how this would work from adding it up. So I'm going to rewrite it down here. We have the sum of n equals 1 to 5, 2 plus 3, n minus 1. Okay, so this is what this means. What we're going to do is take the numbers 1 through 5, plug them into this equation. So we would do 2 plus 3, 1 minus 1. Plus, now we would take the next number, which is 2, and plug it in. And then we would take the next number, which is 3, and plug it in for n. And then we would take the 4 and plug it in for n. And then lastly, we would take the 5 and plug it in for n. And what we would do is we would evaluate each of these and we would add them together. So let's see. 1 minus 1 is 0, times 3 is 0, plus 2. 2 minus 1 is 1, times 3 is 3, plus 2 is 5. 3 minus 1 is 2, times 3 is 6, plus 2 is 8. 4 minus 1 is 3, times 3 is 9, and 2 is 11. 5 minus 1 is 4, times 3 is 12, and 2 is 14. And then you would add all those up, and you would get 40. So the sum of 2 plus 3 times n minus 1 for n's from 1 to 5 equals 40. And that's how summation notation works.